A day will come when our sun sets but will never rise.
Hey guys, welcome to Mr. Jam's channel. Today's topic is quite interesting, so watch it till the end. And if it's your first time, don't forget to subscribe and hit the notification bell. Nothing lasts forever. Things you observe, places that exist, people that you meet, stars that you see. One day everything will finish, and it's just a matter of time. Our sun is the light for our solar system. It is the fuel for our planets. It is the heat for our surroundings. And most importantly, our sun is the life for our home, which we call Earth. This system has been running smoothly for more than 4.5 billion years. But the sad reality is, time will come when the glow of our solar system will fade away. The system will collapse as our sun slowly burns the last remaining reserves of its fuel. About 4.5 billion years ago, clouds of rotating gas and dust collapsed due to their own overwhelming gravity. This strong gravitational pull forced most of the material towards its center, forming a disc-like structure. Just millions of years following this formation, extreme heat led to a chain of fusion reactions. The sun, as we see today, is the result of these reactions that have been taking place since the early times. The sun is 109 times wider than Earth and accounts for more than 99.8% of the total mass of our solar system. It is 333,000 times the mass of Earth. It is so large that we can fit 1 million Earths in it. The sun's surface temperature is 5,500 degrees, while the inner core is 15.5 million degrees Celsius hot. The light from the sun reaches our planet in about 8 minutes. This light is the source of energy and life on our planet. But sometimes our sun becomes quite angry, and in addition to the light, it often emits solar storms and solar flares. These are the charged particles released from the sun's outer atmosphere. They travel at a speed of 450 kilometers per second, covering the whole of our solar system. They can be quite damaging. But the Earth's magnetic field called the magnetosphere protects our planet from such charged particles. But there had been instances where the solar storms were so fierce that they pierced through the Earth's magnetosphere, causing havoc. The famous solar storm hit our planet back in 1859. On that night, telegraph communications across the globe jammed, setting papers ablaze. Colorful auroras illuminated the night skies, and birds started to sing, and laborers started their morning chores, thinking that the sun was about to rise. This solar flare carried the energy of 10 billion atomic bombs. Quite recently, a 1989 storm in Quebec disrupted the power distribution system in Canada and created powerful auroras that were seen as far south as the state of Texas. As our world becomes more reliant on electronic communications, our GPS and satellite systems are at great risk, which can cause trillions of dollar losses should such event takes place once again. Our sun is a ginormous gaseous ball mainly made up of hydrogen and helium. Hydrogen burns into helium, producing 600 million tons of solar radiation every second, which is dissipated into space. It is estimated that this process began 4.5 billion years ago, and it has been generating energy ever since. Just like stars in our cosmos, after glowing for billions of years, eventually run out of fuel, our sun, being one of them, will experience the same fate. Sun's brightness has been increasing gradually. In about 1 billion years from now, the sun will be 10% brighter than its present state, thereby increasing heat which will directly impact Earth's habitat. In 3.5 billion years from now, the sun will be 40% brighter than it is right now. This increase will cause the oceans to boil, the ice caps to permanently melt, and all water vapor in the atmosphere to be lost to space. Our oceans will eventually evaporate, and the surface will become too hot for water to form. Under these conditions, life as we know will be unable to survive anywhere on the surface. Our home will become just like another hot and dry Venus. This will mark an end to the life on Earth. Our sun's fuel is finite, and it will undergo a typical star's death in another 5 billion years. This will be the time when it will completely deplete its supply of hydrogen. Through continuous burning, the hydrogen in the outer core of the sun will run out, leaving an abundance of helium. When that happens, some extreme events will take place. With its internal energy source shut down, gravity will cause the core to collapse. That collapse will generate enough heat to expand its outer layers. As a result of this expansion, the sun will become 100 times bigger than its current size. At this point, Mercury and Venus will be completely engulfed by the sun. The icy worlds beyond Neptune will melt, unlikely to survive the death of our star. Our sun will grow beyond our imaginations, so much so that it will swallow the inner planets, including Earth. That's when the sun will go into a red giant phase. Near the end of its nuclear burning phase, the forces of gravity will eventually take over. All the outer material will dissipate, and the sun will shrink into a white dwarf. This will happen in about 10 billion years, when our sun finally cools down, unable to produce energy of its own, roughly the size of Earth in the solar system, which once used to be bright, full of energy, now dark and lonely in the deep space.